Hello everyone, in this video I am going to teach you how to remove a duplicate element from the given linked list, from the given sorted linked list. See, now this is sorted linked list. Here data elements are 8, 12, 13, 13, 7. Now what you should do, first step is you should find whether there is a duplicate element. See here, now 13 is repeated twice, so there is a duplicate element. Now second step is you should remove the duplicate element one time. So here 13 is repeated twice. Here 13 is 2 times, so you should remove 113 from this. You should remove this node. Only one time 13 should be present. So that how to do, let's see. See now this is the linked list. Now first step is you should create two pointers called P and Q. See here, P, this is pointer P and this is pointer Q. This pointer P should point towards the first node and Q should point towards the second node. Now how you can access first node? You can access through head, because head is a pointer which points towards the first node. So you should write P equals to head, pointer P should be equals to head. Then P equals to head means P is 100. So this pointer P points towards the first node. Now Q should be equals to 200. How you can access 200? You should write Q equals to P next. P is 100, hundreds next is 200. So you should write Q equals to 200. Then Q will point towards the second node. This pointer points towards the second node. Now next step is you should compare the data present in these two pointers. Now this pointer P is pointing towards 100. 100's data is what? 8. And Q's data is what? Q is 200. 200's data is 12. Now you should compare whether 8 and 12 are equal or not. No, they are not equal. So what you should do? Now you should move P and Q one step forward. So this pointer, how you can move P one step forward? You should write P should be equals to Q. If you write like this, Q is 200. So you can change P value to 200. Then this pointer points towards second node. Now you should move the pointer Q to one step forward. It should point at 500. How you can point? You should write Q equals to P next. Now see, Q is pointing at 200. Now you should change this 200 equal to P next. P is 200. 200's next is 500. So I am changing it to 500. If you change to 500, this pointer points towards this third node. Now again you should compare the data present in these two nodes. Now see, P's data is what? 200's data is 12 and Q data is 500's data is 13. Now compare whether 12 and 13 are equal or not. No, they are not equal. So you should move P and Q one step forward. How you can move? Do this, P equals to Q. Now Q is 500, make this as 500. Now this pointer points towards third node. P points towards the third node. Now Q equals to P next. So this P is 500. 500's next is 700. So I am making this Q as 700. Now this pointer points towards the Q pointer point towards the fourth node. Now again compare the data present in this two pointer. In this two pointer or two nodes. See, P data is what? 500's data is 13. Q's data is 700 data 13. Now 13 is equals to 13. Now what you should do? You should remove this 13, one node from this Q node from this linked list. How you can remove? See here. Now this third node is pointing towards the pointer of third node is 700. It's pointing towards the fourth node. You should remove this node. So that means what you should do? You should not make a link between these two. You should make a link between third node and fifth node. How you can make? See here. Now instead of 700, you should write the address of fifth node, 900. How you can make? See. Now P next, that is the pointer of the P node. 500 next, 700. P next should be equals to Q next. See, Q is 700. 700 next is 900. So Q next. You should write this step. Then see. Now you should make this condition. P next. What is 500's next? 500 next is 700. You should change this value. You should change this value to Q next. Q is 700. 700 next is 900. So write here 900. Then this link will be cancelled and it creates a link between this element, third and fifth node. Now see, now you have created a link. Now this Q node is simply written. Now you should remove it, otherwise there is a memory wastage. How you can remove? See here, you should write free Q. That means this Q pointer, this node will be deleted. Now you have deleted this node. Now there is a link between these two only. So there is a link between these two nodes. Now the 13 is written only once. Now check, again check. See, now you should make Q equals to, you should create a pointer Q, because now you have deleted that pointer. No. So I should write Q equals to P next. That means see, P is, I should create a pointer Q. That pointer is equals to P next. P is 500. 500 next is 900. So I am writing here 900. Now 900 means it's pointing towards, now this is the fourth node. It's pointing towards fourth node. Now check again the data present in P and Q. Now P is 500. 500 data is 13. And Q is 900. 900 data is 17. Now whether 13 and 17 are equal? No, they are not equal. So move P and Q one step forward. So how you can move? P should be equals to Q. So Q is 900. Make P as 900. So this P pointer points towards this node. And Q should be equals to P next. So P is 900. 900 next is 0. So make Q as 0. So this pointer does not point. It points to the next node. But no node is present after this. So Q is 0 here means it's not pointing to any node. Now you should stop. Now you have finished the linked list and you have removed the duplicate element. This is how you should remove the duplicate element from the linked list. Now I will teach you how to write the code for removing the duplicate element. See here. See, this is the function remove duplicate, to remove the duplicate element from linked list. Then this is the pointer head. This head pointer which is pointing to a node having structure. So I am writing struct node. Now see. Now at starting I have created a two pointer called P and Q, which is pointing towards the first node and second node. So I am writing S here. Pointer P struct node equals to, this P is pointing towards first node. First node is accessed by head. So I am writing P equals to, pointer P is equals to head. Then Q should be equals to second node. How you can make? That means Q should be equals to P next. P was 100, 100 next is 200. So Q is pointing to P next. So I am writing SC. Pointer Q, that is struct node. Q is equals to P next. Now see, now you have created a two pointer pointing towards the first node and second node. Now what you should check? First you have checked whether this data element present in P and Q are equal or not. This 8 and 12 are equal or not, you have checked. So how you can access? Your P is pointing to 100, Q is pointing to 200 at starting. So you should find P data and Q data whether they are equal or not. So I am writing that condition. See here. If P data not equals to Q data. See, what is this? I am checking if 8 is not equals to 12. This is not equal, right? Then what I should do? I have moved P pointer one step forward and Q pointer pointing to one step forward. So how I did? I have written P equals to Q, then Q equals to P next. So I am writing that. See here. P equals to Q, Q equals to P next. Now again I should go back and see. Now you have moved the pointer one step forward, P and Q one step forward. Then what you should do? You should again check this condition. You should go back and again check P data and Q data whether they are equal or not. Now P was pointing at 200, Q was pointing at 500. Now you are checking 12 and 13 whether they are equal. So you should go back again. Till how much you should go back? Till Q is not equals to 0. You should move P and Q pointer till all the elements till q is not equals to 0. So I am writing the condition. See here, while q not equals to null. Now see, in this case p is at 900, q is at 0. So q is equals to null, so it does not enter into this condition. It does not enter p data not equals to q data. P is 900, 900 data is 17, but q data you can't access because no node is present. So it does not enter here, it stops here. So that's why this is the terminating condition. Now see, this is when when this 12 is not equals to 13, that is when no duplicate element is present. Suppose in this case, when here one node was present and 13 was present there, in that case 13 was equals to here 13, then what you should do? So I am writing the else condition. Else p next equals to q next. See, this pointed part of this third node was 900, that is p next. P was pointing at 500 before, so 500 next is 900. You should no 500 next was 700 before. Here one node was present, so 700. So you should update that 700. So I am writing here, p next is updated to q next. Q was pointing at here 700, one node was present. So you should store the address of this node into this pointer. So I am writing the address of this node can be accessed by q next. So I am writing this step, p next equals to q next. So that's why I am writing here. Now I have updated, so there the link gets the link connection gets between this and this node. Now what I should do? Now one empty node was present, q. I should remove that q because it causes memory wastage. So I am writing free q. Free q. Now I have removed that q. Now what I should do? Now I should create now q pointer is not there. So I should create a q pointer which is pointing one step forward of p. P is pointing at 500, means q should point at 900. How I can point? That step is q equals to p next. P is pointing at 500, means 500 next is 900. So q should point at 900. So I am writing this step. Q equals to p next. So this is the code. This is the code how for finding the to remove the duplicate element from the linked list. That's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.